Hello everyone, good evening. In this session, we will discuss about a platform or a framework called Flink. And Flink is a very popular platform that is used for real-time data processing. Now let us talk about Flink and how Flink processes data in real time. First, we should talk about stream processing of data. Streaming, that means data coming continuously. This data, uh, like example, data from Internet of Things, data from applications. Today we have click data, the number of users visiting the website, clicking the products, finance data, the transactions that are done online, log data, sensor data again, which is again Internet of Things. We have lot of data that is continuously coming, and this is different, and we need a different processing techniques to handle this type of data. Data is no more static, it is continuously coming, and you cannot save this data and process it later. In today's world, people are keen to know the real time insights. For example, a stock market application, they want to know what are the top performers within a given minute and what are the top losers in the stock market in a given minute. If you take online gaming, these food delivery apps, all are generating data in real time, that is again continuously, and this data has to be processed continuously. Let us say a real estate application. They want to track changes in real time continuously. So all these data need to be captured continuously and processed continuously. Anyway, to capture this kind of data, we have data streams. Data streams, they can continuously collect data. Like Kafka, in AWS, we have Kinesis. In GCP, we have PubSub. And there are many other open source platforms which can collect and deliver this data continuously. But just capturing the data continuously is not sufficient. Getting insights or processing that data in real time, like generating real time alerts. Sensor data is coming. As soon as the data comes, within less than a minute, within milliseconds, you have to raise an alert, create an alert. Logged data are coming. These are application logs. This tells the application performance and the number of visitors visiting the application. Everything will be in the log data. Now you have to process that data in certain time window. Let us say for every 5 minutes, you'll see the number of visitors has visited in that 5 minutes. For every 1 hour again, you'll see what is a peak time and what is a ideal time within a given hour. And for this, you have to process the data in real time. Like that, finance data, click-through data, IoT data, all are continuous data, and these needs continuous processing. And we have very good libraries in languages like Python to process data, right? Python and PySpark. These languages, we have very good functions, libraries, which allows you to transform data in a better way. And SQL also. You can query and do transformation to some extent. But all these can handle batch data, because batch data is static. It will be having fixed number of columns and rows. Especially the rows, we will be have fixed amount of rows. So all these languages, libraries which we have in programming languages and in our traditional processing, they are used to process static data. But stream is something, the data will be continuously coming. It is not fixed. You don't know the end of the data. It will be continuously coming. And we need special frameworks now which can process that data. The existing libraries are designed for static data. This is something dynamic data. The size of the data will be growing, and it will be growing, ever growing, because data will be continuously coming. And we have some frameworks which can handle this kind of data, like Spark structured streaming. That is one platform which has libraries that can handle streaming data. And one more framework is Apache Flink. And there are few other bunch of names I can mention, but these two are very popular. Spark structured streaming, Apache Flink. And now here we are talking about Apache Flink. Its mainly it is designed for real-time processing, stream processing. Of course, you can also do batch processing here, but the main uh, like point here in Apache Flink is it has been designed for real-time data processing or stream data processing. So what is that stream data processing? How Flink processes data? We will discuss about that. And why stream processing? Because we cannot wait for certain insights. We need instant insights. We cannot wait until the data piles up to a batch, and we cannot get insights out of it. Something like raising alerts, overheating alerts. Say, for example, you are collecting data from a machinery and you have to raise a overheating alert so that machinery will be shut down. You can stop causing the damage even before the damage occurs. You can stop it proactively. We can make decisions by processing that data in real time. Suppose all the sensor data is coming, you pile up it, and daily you will do processing on that data. Then the insights which you get is of no use because damage is already done. In such scenarios, you need instant insights. Right, and applications like stock marketing, predictive maintenance, and these days we are getting personalized recommendation. And you might have experienced with these flight tickets. And when you book tickets with respect to time on the demand, the number of users trying to book that flight, they'll increase the price. If more number of people are trying to book tickets based upon the traffic, they analyze the traffic in the real time. They'll get to know the numbers, how many people are trying to book that particular ticket. Based on that, they will raise the prices. So all these are happening based on stream processing of data or real-time processing of data. And also one more advantage with real-time processing is once you process data, something like raising alerts you have already done, you need not store all the data coming from your sensors, which are second by second or minute by minute. You don't need to save them as it is. You can aggregate them or summarize them because you already got the insights in real time. For later historical insights, you can aggregate them or summarize them and save, which will lower the cost of storage and processing. So these are some other benefits we have. Stream processing is nothing but as soon as data comes, within less than a second, in few milliseconds, you have to extract a insight that has a business value. That is stream processing. Sorry for that, guys. Now let us see Flink, how Flink does the stream processing. And what is this Apache Flink? It is a framework. Just like we have Python, SQL, and SQL IDE, you will run the SQL code. In Python IDE, you will run Python code. Like that, the same Python, the same SQL, if you want to apply on streaming data, you cannot do it on your regular Python interpreter or a regular SQL applications. There is a special framework, and this framework can use distributed processing. That means multiple computers together. You can form a cluster, and Flink can run on it, and a distributed processing engine. And this Flink framework is nothing but a software, and this software can run on distributed environment, that is multiple computers together can host your Flink environment. On this Flink, you can use Python language and SQL, Scala, and Java. Meaning in these languages, we have special libraries which support real-time streaming. But these special libraries, they'll work on only Flink environment. When you use Python on Flink, it's called PyFlink. When you use SQL on Flink, it's called streaming SQL. And then you have Scala and Java also, which you can run on Flink. And the most used option are Python and SQL. And you can see on my screen, there is a comparison between a traditional transactional application and an event-driven application using Flink. A traditional application, events, transactions made or coming, that are the events. And application is running which accepts the events and triggers some action. Like let us say fraud detection application. Events are coming, events are transactions made. And the application is nothing but code you have written which has to identify the frauds from the events, and then it has to trigger some action, raising an alert, something. So what happens here, the events are coming to the application processes the events and writes into transactional database, and again the application reads that application, or other application reads it, and it identifies the fraud detection and triggers the action. Why? Because to know about, to compare with previous transactions, the application has to read the previous transactions, and it has to compare it with the existing event. And if there is any suspicious activity detected, then it will trigger the action. There is a lot of latency involved here. Now let us see the event-driven application using Flink. Events are coming, events or transactions made in a finance system. And event log is collected by some streaming platform like Kafka. And the collected data will be ingested into Flink. So Flink also saves data in some persistent storage, just like transactional DB. But it maintains something called state. What is the state of previous events? Now it compares with that state, accordingly triggers the actions almost instantly, within milliseconds. Flink doesn't every time read the database and compares. Comparison like in a traditional application is not happening here. It manages the previous state of the events coming in. That is why Apache Flink is a framework that works on distributed environment and also uses stateful computation over unbounded as well as bounded data streams. Flink also supports batch data processing. Unbounded means continuously coming. In a continuously coming data streams, Flink manages the state, that is state of the earlier events, and processes the data. That is a specialty of the Flink and triggers action. So this is one feature of Apache Flink. We will understand more about Flink by taking a use case. Before going to the use case, these are some core concepts which we are going to discuss. Event time versus processing time, watermarks, windows, stateful operators. These are the key concepts to understand Flink processing, Flink computing. So this is nothing new. The computation wise, it's like a computation using Python or a computation using SQL. We have certain operators, certain terminology that you only use in Flink. They'll not work in traditional methods. And those are here on my screen: watermarks, windows, stateful operators. Let us discuss about them. First, we will understand event time, processing time. Now we are talking about streaming data, data that is continuously coming. Sorry again. When data is continuously coming, there are three types of time. When data is continuously coming, meaning they are collected continuously. Collected continuously by data streams like Kafka. Say, let us take transactions. When transaction is made, that is event time. When the event actually occurred, that is event time. Say transaction 1. This transaction 1, something like this. Let me clear this. And write over here. Transaction 1. It is like this. ID, account ID, let's say. Type of transaction. Amount. Location. And along with that, event time. So this is transaction happened, and these are the attributes we have in it. Event time is when actually the transaction happened. And we need to capture this in real time. For that, we will use something called data streams. We will ingest into the data streams. That is ingestion time. When event enters into streaming system. These days, streamings are providing very high throughput. In less than a millisecond, they were delivering data from producers, which ingest data to consumers. So streams, they collect data from producers, deliver to consumers. And on consumer side, I am doing real-time processing using Flink. So there are three types of timestamps here. One is the event time, when the transaction happened, and you are ingesting into the data stream, that is ingestion time, and then you have processing time when event is processed by the system like Flink. So let us say some network delays or application downtime. This transaction might arrive late at the Flink. That means late processing. Right. This is an issue which we have to address in stream processing. Out of order arrivals due to the network or system delays, or late arriving events, arriving after expected window of processing. So these are some issues in stream processing. Now we understood what is event time, processing time, and ingestion time. Now let us also discuss how Flink processes the data in real time. For this, we will take a use case, real-time fraud detection. Every second, thousands of payments, events will flow in. And from different systems, this data will be coming in. See here, event time is when the payment was actually made. Processing time when Flink receives it. In between, we have an ingestion time, but we are talking about Flink, right? Event time, if there is any delay at ingestion or any network delay or system delay overall together, the time at which data arrives at Flink, we are calling it as processing time. Okay, so payment made at 12:02, that is event time. If Flink receives at 12:05, 5 seconds delay is there, that is processing time. And the solution to address these kind of delay is watermarks. Flink uses watermarks. Right? Watermark let us wait 5 seconds to capture late payments also. You see here I have inserted an SQL query where we are creating a table, and this table we are creating for Flink. And in this table payments, this is not a regular table. This is a table which accepts data from stream. So the data that is coming continuously, you will put into this table. Transaction 1 will be the first row, transaction 2, second row, transaction 3. This table is not having ending. Like this, you as soon as data arrives, you will write into this table. When you want to process data using SQL and Flink, you can use table APIs. And you also have a stream API. You can use Python, Scala, Java on that stream API. Since SQL is easier as a beginner, I'm using SQL statement here. While defining this table, I am using watermark. See, watermark for 5 seconds. While defining watermark, you have to provide the column, timestamp column, event time. And you are mentioning that wait for 5 seconds. If there is any late arrival, wait for 5 seconds and accept the data. If the data arrives more than 5 seconds, then Flink will either drop it and process it separately. Because something like fraud detection, data will be continuously coming. In a given window of 5 seconds, or let's say 10 seconds, you are observing the transactions that are made. So there is user 1, some person, let's say user 1. User 1 has made 3 transactions in a time window of 10 seconds, which is a suspicious activity. from different places. Right? When you are doing this detection, some other data is also coming. It's a late arrival, and we are keen in within this 10 seconds window. Suppose some data arrived very late, 15 seconds late. That means that data belongs to previous window, previous 10 seconds window. It has to be part of that window, but now it arrived. We cannot consider it because we are checking within a 10 seconds. The user cannot make more than 3 transactions or 1 transactions. Logically, more than one at a time within a given 10 seconds or 30 seconds also. User cannot make more than 1 transaction. If it is happening, then it's a suspicious activity. If you consider the late arrival also, then unnecessary interpretation of data. So that was data point 15 seconds ago. If you consider it here, then you have to raise a fraud alert. Sometimes data might arrive little late than the event time, but we cannot discard that data. So you have to logically choose one watermark. Here 5 seconds for fraud detection is convincing watermark. Yes, if data arrives bit late, up to 5 seconds we can wait. If it arrives too much of late, then we can process it separately or we can drop it in that window. That is how Flink handles data. See, one of the challenge in stream processing is addressing late arrivals. And in Flink using watermark, you can handle that. See, here I am using SQL on Flink. It is almost like regular SQL. Only the thing is you are mentioning the watermark, that's it. We are creating a table in like a regular standard SQL. And we are mentioning additional details like connector Kafka, that is where data is coming. Topic payments. In Kafka, through payments, the continuous data is coming. So the data will be collected from this server continuously and ingested into this table. And this table accepts data if there are any latencies like plus or minus 5 seconds. So this is one feature of Flink. Windows. Now, if you want insights like fraud patterns, see, there should not be more than 3 transactions that is greater than $1,000 within a 1 minute by the same user. If it is happening, then something suspicious is happening. Because the banking system, the online banking system, will not allow to do that. Technically, it is not possible. In a 1 minute, more than 3 transactions. And how you can identify these kind of patterns in real time? Because data is continuously coming, you cannot do some transformations on your data. Like if you want to filter, you can filter data that is continuously coming. If you want to check some threshold and categorize your data, you can do that. Let us say sensor data. See, sensor data is continuously coming. First reading, you have to filter some attribute. You can do that from the first record, then second record, then third record. You can apply filter continuously. You want to check some threshold and you add a new column. Like temperature is greater than 50 or let's say 70. A overheat alert. One more attribute you are adding. You can categorize in real time. But in some scenarios, when you want to group and do some operations, suppose you want to sort data, You want to calculate minimum, maximum, counting. How can you count a data that is continuously coming? The count will be changing. In fraud detection, I want how many transactions made in a minute. I cannot do that because it is data coming continuously. I want to know the maximum amount, maximum transaction that was made. You cannot do that because data is continuously changing. This minimum, maximum, averages, everything will be fluctuating. This data is not static. And that is where in stream processing, we will use windows. See in here, SQL, using SQL on Flink, this is the code where we are using sliding window. In a 1 minute window, we are observing for every 10 seconds in a 1 minute, what is the count of payments that are greater than 1000. And also we are grouping by user ID. This seems like a regular SQL, but there are few terminology like this tumble start. That means you are fixing your time as 1 minute. And then from that tumble, that is in 1 minute, sorry, here these controls are blocking. Let me move them. You are observing the values for every 10 seconds. So that if there is any appearances of transaction in this window more than 3 times, then you will raise it as a suspicious activity. For this, the amount of time it takes 1 minute because you are grouping by 1 minute. So in a 1 minute, if there is any fraud really happening, you can address it in a 1 minute. So that is real-time processing. And according to the use case, you can plan more continuous insights also. So watermark is one feature. This is your regular SQL, but with some additional features like watermark. Windowing is one more additional feature. These windows you can write in Flink only. In your regular SQL IDs, this might throw error, windows, watermarks. And stateful operators. You are comparing it with the previous state. Detect total amount per user in a 1 minute window. Here we are putting a threshold 3000. In a 1 minute interval, right? Again, if user is in 1 minute or a 10-minute window, you can raise it to 10 minute also. If user is trying to make one more transactions that is greater than $3,000, you will check the last transaction also. If it is greater than 3000, you will compare. Accordingly, you will raise a suspicious activity alert. So that is stateful operators. Checking the history of the user's transaction also. So these stateful operators, windows. See here you are using keywords like hop, which allows you to select the intervals. We have tumble windows, sliding window, which is hop window. And you can create watermarks. Using these stuff in SQL is nothing but how you process data in Flink. And like we have watermark windowing in SQL, we have same set of libraries. I mean equivalent set of libraries in Python also. Python, Scala, and Java. libraries which supports the same. So that is about stream processing on Flink. Yep. Thank you guys. If you have any doubts, you can ask. Okay then, thank you.